So the idea of this tiles activity sheet was to get you to make a connection that you can do something to this number to figure out what this number would need to be so that this is truly a perfect square. So hopefully you realize that if I take this middle number, cut it in half, and then square it, I get the number of little squares that I need to finish the picture. So like half of 12 is 6, 6 squared. Half of 20 is 10, 10 squared. So that's kind of the idea behind that. And we have a little visual to kind of help you see why does that exactly work. It's not a magical formula, it's just logic of why that's the case. So we'll take a look at that, and then we're going to talk about these interesting scenarios when you have odd numbers. So if you have an odd amount of rectangles, this is kind of weird. So you're like, well, I need 81/4 little squares to finish the picture. That is a little bit hard to visualize without any manipulatives to actually show you what's going on and why that happens. So we'll take a look at that, and hopefully after you see the PowerPoint, that kind of sticks a little bit better. All right, so let's just pretend that you had to do x squared plus 4x, and you have to figure out, what would c have to be so that you get a perfect square, right? So the idea is, well, you know what, this really wouldn't be here, so we'll block that out for now, okay? Let's say this is a problem. So you pulled out an x squared, you pulled out 4x's. It doesn't matter how many of these x terms you have, you're always going to divvy them up, and you're going to put half of them on the length and half of them on your height or width, however you want to say it. So you're going to put the same amount on each one because you want to make sure it stays as a square. So whatever you add to this side, you need to add to this side so that it's constantly going to be the same length on each side. So it's going to be a square. All right, so that's where that b over 2 comes from. So if you had 400 rectangles, you would put 200 of them on this side and 200 of them on this side. So then where does the squared come from? Well, don't forget, you guys, when you put the same amount on each side, you are creating a square. Okay. Now remember, if you had, let's say you had 400 rectangles, right? If you had 400 rectangles and you put half of them here, these each count as 1. All right, this is 1 unit long, 1 unit long. So whatever b over 2 is, that's going to be the length and the width of this resulting square. So how do you get the area of the square? You take this length of a side and you square it. So that is visually what's going on, is we're just divvying up our rectangles amongst each side. And by doing that, we're creating this mystery square. The length and width are going to be however many rectangles we needed on each side. So that's kind of the idea behind that. But what happens when you have an odd number of rectangles? So for example, this right here is a visualization of x squared and 5x. Okay. So how do you visual or draw what's going on when, if I had 400 rectangles, I know to put 200 on each side. That's easy. But how do you do when you have an odd number of rectangles? Well, you're going to start out by divvying them up still, right? So we're going to put 2 of them here and 2 of them here. So the question is, well, what do I do with this guy? Because if I put him here, I don't have another one to match him, right? So that's not going to keep this a square. This is a square as of now. Well, there's no law saying that we can't cut it in half. So if we cut it in half and put 1 of them on each side, we have some fractions in the picture now, but we still have a square. The length and the width are the exact same. And then I kind of go about my business. I need to fill in with little 1 by 1 squares on my empty spots. So I have 1 here, 1 here, 1 here, 1 here. But obviously I don't want to put a yellow square for this. That's going to be way too big. Well, that's okay. Just like we did with the rectangle, what if we cut the yellow square in half? Think about that for a minute. It used to be 1 long. Same thing with this. This used to be 1 long. but now this is a half long. Well, so is this. So I'm absolutely allowed to slide this little half of a yellow, which we'll call purple. We're allowed to slide this in here because this is 1 by a half. So the sides are truly the same length. So what I need to do is get myself yet another yellow square, cut it in half, and put those two guys right here. So I still have a square. I have, this is x, 1, 2, and this would be the leftover. And I have x, 1, 2, and this part right here would be my leftover. I have x, 1, 2, and a half, x, 1, 2, and this should end up making a square. So I'm still following the rules of a square. I have not changed the dimensions or anything like that. But then how do I figure out what needs to go here? Well, if I take a purple block and I cut that in half, that's going to fit very nicely right in here. Why is that the case? Well, because remember, this is 1/2 wide. So I need this little square to be 1/2 wide. Well, if I take this, which is 1 by a half, and cut it in half, now this side is a half and this side stays a half. So I have myself a perfect square. I just had to do some cutting. Not very convenient, which is why odd numbers are annoying and using a formula is much more convenient, but is actually absolutely possible to represent this visually. So let's keep in mind the area of the blue tile is x squared, right? X by x. The area of this rectangle is x. So then this was half of this, so therefore the area should be 1/2 x, right? The area got cut in half. And my yellow tile is still an area of 1, that didn't change. But if I were to cut it in half and call it this purple figure, what's half of 1? A half. So the area of the purple is a half. But remember, to get from purple to the black square, or to get from the purple rectangle to a black square, we had to cut that in half, which results in 1/2 by 1/2, and that would get you 1/4. Or you can just think, what's half of a half? A quarter. So I have all the areas of these different shapes, and just by simple logic, if you want the area of this square, you can just add all these shapes together. All right, so let's add them together. So I see that I have 1 x squared tile. I have 4 of these x tiles. I have 2 of these 1/2 x tiles. I have 4 of these 1 by 1 tiles. I have 4 of these half tiles, and I have 1 of these 1/4 tiles. So I just have to do a little bit of combining and cleaning up here. So let's see where this gets us. So we have x squared. I'm going to go ahead and say 2 times a half is 1x. 1x and 4x is 5x. I have a 4. 4 times a half is 2. And 1 times a quarter is 1/4. Can still do a little bit more cleaning up. So we'll combine our like terms. 4 plus 2 plus a quarter is 6 1/4. And that, of course, you know, if you don't like mixed numbers, that is the same thing as saying 25 over 4. So I'm able to generate how many of these little squares I need. Instead of saying, though, I need 25 quarters squares, I wouldn't say it like that. I would just say I need the area of these little squares to add up to 25 fourths or 6 1/4. That's going to involve some cutting and stuff like that. But I wouldn't say you need 25 quarter squares. I mean, that is true. I would just say I need the overall area of those squares to add up to 25 quarters. So you can absolutely think of it, you know, logically what's going on with a picture, right, in geometry world. Or if you want to use that b over 2 squared mentality, right, I took the number of x's, I had to split them up, And then I had to fill in missing spots. If I do that, well, b is 5, right? So I have to do 5 halves squared. And if I do that, I get 25/4. So just because you have fractions doesn't mean it's not doable, and it doesn't, in geometry world, make logical sense. It's just obviously less convenient, and the more cutting you have to do, the more work you have to do. So that logic of, oh, you know what, divvying up those triangles and then whatever that length is, squaring it, that's going to get me the area of this. That's going to save you a lot of time and effort.